PopUnders are like pop-ups, just a lot more annoying. The goal is to open a pop-up in the background, pop under the current window, so that you won't see it until you want to close your browser and you don't know which site created it. Creating a pop-under used to be fairly easy because there are actually functions called blur and focus, which exist solely to focus an element with focus or prevent focus with blur. So you would blur the pop-up window you open and focus the current main window. And that technique still works in, for example, Edge, but Chrome will always try to focus the new window, thus preventing pop-unders. But I did some research into this and found a demo site that actually is able to create a pop-under, which obviously caught my attention. This guy even sells a license for a JavaScript library that can create pop-unders in any browser, and ad networks pay good money for it. So I wanted to know how this script manages to do a pop-under on Chrome 59, as other libraries can't do that. So I started to analyze it. Let's check out the demo for the pop-under. I clicked the link, and yes indeed, here is a pop-under. Let's try to figure out how it's done. Obviously, one of the first ideas is to look into the sources. The solution should be right there. But shortly after you open the developer tools, a debugger statement triggers a breakpoint, and you can't just continue, as this is constantly called on a timer. It's an anti-debugging attempt. You can disable breakpoints entirely, but then that also prevents you from setting breakpoints in the sources themselves, and you would want that for debugging, so that's annoying. But first, let's look generally at the scripts. The main page loads a loader.js file, which loads 3 other scripts: scripts.js, license.demo.js, and demo.js. Let's have a quick look at each of those. Demo.js seems to be the script a potential client would use. It configures the better.js pop module and allows developers to react on before and after pop-up creation. Otherwise, not much else is there. The real functionality is probably in better.js pop itself. License demo could be interesting in how licensing works, but when you look at the code, it's heavily obfuscated. Even if you pretty print it, it's completely rubbish code. And script.js, which is presumably the main script, looks similar. There are some easy functions and nonsensical functions which you can clean up, like these here, just return the argument or perform simple operation, but even if you clean that up, it still looks terrible, and it's long. So how do we figure out what it does? I will go now over the path I took, but it would be awesome to hear from you how you would have approached this, as I'm sure there are many different techniques to go about this, and I don't know if I know them all. So the first thing I did was mirror the whole site locally. I didn't really test it, but I assumed if they put so much effort into licensing for domains and have a demo here, that these scripts will check the domain they are loaded from and won't function properly if loaded from somewhere else. So you can't simply use the demo on your site. That's why I not only downloaded each file and placed it in the same path, but also modified etc hosts to point the domain to localhost. This way, when I visit the site again, it attempts to load it from 127001, which means we can start a simple PHP or Python server on port 80 and load the site in the browser. And make a small modification to the local file and remove the embedded video and image and clean up the site a bit. Now you can easily see that it loads this version instead of the live web version. So the reason why I want a local mirror is that I have all the freedom of modifying and playing around with it. But where do I really start now? In theory, in the end, the JavaScript code will have to call the main API functions. Functions like window.open and window.setTimeout, or like createElement or appendChild. But we can't easily search for this in the script, as these calls are heavily obfuscated. But we can try to hook or proxy or intercept those calls. This way we can learn more about what's happening. I'm using a proxy object for this. It's like a web proxy that sits between you and your destination. A proxy object in JavaScript sits between the caller and the actual function target. The proxy object is used to define custom behavior for fundamental operations, for example, property lookup, assignments, enumeration, or function invocation. So now I'm defining a handler function that can be used to intercept and log all the function calls. And then I can override functions I want with a proxied version. And because we want to learn more about pop-ups, I wanted to intercept window open, which is the function to open a pop-up. Oh, and I write this code before the loader loads the other scripts, so I can override any functions it would use. I disable the breakpoints and reload the page. But when I click the link, I don't see any call to open, which is super weird. But in the console, I notice 2 deprecation warnings, and one of them is interesting. Deprecation, using the notification API from an iframe, is deprecated and will be removed in Chrome version 61 around September 2017. You should consider requesting permissions from the top-level frame or opening a new window instead. Wait, that's so weird. First, why the heck does it call the notification API? What does it have to do with the pop-up? And what's up with the iframe? I feel like this must be a key component, some kind of trick to achieve a PopUnder. As there are no iframes in the HTML code, let's see if we can hook the dynamic creation of those iframes. It probably uses the createElement, appendChild, and removeChild functions to achieve that. So let's proxy these. As appendChild could be called on any HTML element, I can use the prototype of the general element object to override the function for all elements. If we reload the page now, we can already see that it works with some div. But let's see what happens when we click the link. Look at that. It creates an iframe. Unfortunately, we can't inspect what the iframe is for because later the iframe is removed with removeChild. Around this time, I started to get really curious about the stuff that pops up briefly. So weird. So I decided to record it in order to slow it down and see what happens. And when you go step by step, you first notice a pop-up window being opened in the bottom right corner, so the user might not really notice it. Then the notification permission request pops up, and around the same time, an alert box is shown with Chrome PDF Viewer. What the fuck? And then they disappear again. What the heck is going on? At this point, I realized what seems to be the basic idea behind all of this. To create a PopUnder, you somehow want to get the main window back in focus. And it looks like with this weird combination of notification requests and alert box, you can get back the focus of the main window. Knowing this, let's move on with some debugging. The removeChild prevents us from inspecting the iframe, as it's gone by that point. So instead of calling removeChild, let's override it with a custom function. We could use the proxy object and not call the original function, but I just wanted to show another method how you can change the behavior of something. A proxy object is cleaner, but this works also well. So now instead of removing an element, we log the element it tried to remove. And let's try it again. And it looks like that removeChild was necessary to remove the notification permission request and the alert box because they stay now here. But we can also look now into the iframe. It basically just defines a function mkp which calls window.open. That's the trick used why we couldn't proxy window open, because here they will dynamically create an iframe and use its clean new default window open function instead. This is not meant to throw off analysis, it's actually a simple pop-up blocker bypass. Some basic blockers simply override window open like I attempted to do, and with this trick you can get back the original window open function. So it's just a bypass for simple pop-up blockers. You can also check that window mkp, which I guess stands for make pop-up, exists here in our global scope pointing at window open. So clever. But let's move on, because a few steps later there is a second iframe created, and if we look into that one, we see that it executes a script that requests notification permissions. So that's why we get the deprecation warning here. Not sure yet why notification permissions are requested, but now we know when and where they do it. At this point, I felt I understand what was going on more and more, and I started playing around with this knowledge myself, doing simple tests. I first opened a new window and then caused a notification permission request. And as it turns out, with the notification request, Chrome focuses the main window again. But once the user clicks this box away, the focus goes back to the other window. And two things to observe here. First, we get focus of the main window, which is exactly what we want. Question is just how to keep it. Second problem, how do you remove the notification request again automatically? Both shouldn't be really possible, but we know that remove child with an iframe could be the solution, so we can try that. First, we create the iframe and append it to the DOM. Then we execute the JavaScript in the iframe, and after that use a timeout to wait 3 seconds and remove it again. And testing that shows that it works. But what's up with the PDF message we see? When you think about it, it kinda looks like an alert box. So let's play a bit more with our test and remove the iframe with the notification for now and instead call alert. And we get the same behavior. The main window gains focus because of the alert, but as soon as the user clicks it away, focus is restored to the pop-up. Unfortunately, a simple iframe won't help here to remove the alert box because alert blocks and pauses everything. But anyway, we can try to combine these two now, like we saw in the slowed down video, and so we trigger the notification permission request, then we wait a bit with the set timeout and trigger an alert, and then we wait a bit longer and remove the notification again. Let's run it. And when we now close the alert by hand and the notification request is automatically removed, surprisingly, the pop-up window stays in the background. The main window is kept in focus. So last question is, how do they now remove the alert box automatically? It looks like the alert is triggered from the PDF viewer. It said please wait, so I assume maybe it happens if you load a huge PDF or so. I did some tests, but it didn't work out. I also couldn't find useful information about the waiting dialog online, so I decided to take a step back and analyze the demo further. And besides the iframes, there is another element created, an embedded object that defines a data URI of the media type PDF and base64 encoding. So we can decode that and find the raw PDF file, which contains a JavaScript app alert please wait. So it also calls alert just from a PDF, and that's the trick, because that alert box can be closed again by removing the embedded PDF from the DOM. To not steal anybody else's code, we can also create our own minimal PDF that calls alert and convert it to base64. Now everything falls into place. We first open a new window, then dynamically embed a PDF with an app alert and create an iframe that requests notification permissions. And after a short moment, we then remove the iframe and the embedded PDF again. And that's it. If it doesn't work, then maybe you have the timing wrong. It's not 100% reliable. But wow, we created a PopUnder. Wasn't this interesting? Hopefully Chrome will fix this so I don't have to experience these annoying PopUnders anymore.